In lesson 6, still talking about quadratic functions, but we're also going to add in, if you remember, these exponential functions from the last chapter and way back when linear functions, right? Taking a look real quick at the formulas, you know, y equals mx plus b, where m is your slope, your rate of change, your steepness of your line, and b is your y-intercept. The parabolas, here's our function. Remember, a tells us if it's going to open upwards or downwards, and so on and so forth. And then the last one, the exponential, remember x becomes our exponent. In here, x is to the first power. In a quadratic, we have to have x to the second power, and in an exponential, x is the power. All right, so we're going to talk about how we decipher one from the other. Starting with, well, graphing is easy. Line, parabola, and a curve. So let's plot these and determine what they are. First, plotting the points, so negative 6, 5, 1, 2, 3, 4, 5, then negative 3, 4, then 0, 3, 3, 2, and 6, 1, and that makes a straight line right there, so it is linear. Pretty simple. Check out the next one, negative 2, negative 4, then negative 1, 0, then 0, 1, then 1, 0, then 2, negative 4, and there you have it. It is a parabola, so that would be a quadratic. And then this one, probably going to be, you know, here, and then here, and then here, and then 1 and 4, and then 2 and 16 does not even fit, but that one is a curve. I didn't do a very good job with my line because it shouldn't go below the x-axis, but you get it, and that is an exponential. All right, so that's how we determine. But what if they're not giving us the graph? What if we are just given a table and we don't feel like graphing? Guess what? We can analyze the differences between the values. Now, we said we've got something called the first differences and the second differences, and we are looking always at the y values, the output. All right, so what's the difference? So you're going to subtract, find the difference between them. If those first differences, once you find all the differences between the y's, if they're the same, that's your constant rate of change. It's a linear. Now, what if they're not the same? Then you check the differences of your differences, and I'm going to show you this. And if they're the same, that means it's quadratic. And then if neither one of those work, then we look back to the y values and see if they make a ratio. If the next y over the original y all equals the same ratio, then that makes it exponential. Let's look at a couple of these so this makes sense. First differences and second differences, it kind of sounds goofy at first, all right? So top of the back on the first page, we've got 3 examples. You know, I'm going to go out on a limb and say we probably got one of each example here, but who knows? Take a look at this first one. So I'm going to find the differences right here. That is plus 6, that is plus 2, that is minus 2, and that is minus 6. Now, those first differences are definitely not all the same. So let's check my second differences. That means between these numbers. So 6 to 2 would be minus 4. 2 to negative 2 is minus 4. And negative 2 to negative 6 is minus 4. So our second differences are the same. So this would be a quadratic function. So first differences aren't the same, but then I took the differences of those numbers and they were the same. All right, let's look at the second one. Okay, 125 to 25, well, that would be minus 100. Ooh, I'm losing my ink in my pen. Minus 100, this would be minus 20. This would be minus 4, and this would be minus 0.8. So second difference is, let's see, plus 80. plus 16, so not the same. So first differences, second differences, neither one of them are the same. So it's not linear and it's not quadratic. So I'm going to go and check my ratios. So I'm going to take this one and put it over that. So 25 over 125. Well, that, folks, is 1/5. I'm going to do the next one. 5 over 25. And I'm just taking each pair of numbers, which is 1/5. 1 over 5 is obviously 1/5. And then 0.2 over 1 would be also 1/5. So this is exponential. Because the first and second differences were not the same, so then I checked the ratio of each successive pair of y's. All right, let's do the third one. -8 to -3 is plus 5, plus 5, plus 5, plus 5. So the first differences are the same, which makes that a linear. So there you have it, checking our first differences and second differences, identifying quadratic, exponential, and linear. I do know you have some of this on Alex, and I was helping somebody with it just today. So besides just differentiating which one is which, we're also going to write equations. But remember that, you know, we're not going to write the really crazy quadratic equation. So a quadratic function will look like this. So first of all, you probably want to remember linear is y equals mx plus b. That's your slope or your rate of change, and that's your y-intercept. A quadratic, it's simply going to be y equals ax squared, and we will plug in a number to find a set of numbers to find a, and we'll talk about that. And the last one, an exponential, it is going to be y equals the first term times the ratio to the x. All right, times whatever your ratio is. So that's how we write it. So first we have to determine what they are. Take a look at this first one. We have plus 2, plus 2, plus 2, plus 2. So it's linear. Some of you might know some tricks just to write the linear equation, but this right here is our m, rate of change, up 2 over 1. So I'm going to write y equals 2x plus b. Now how am I going to find b? And if you don't know the trick, P.S. it's right here. But if you don't know the trick, put in an ordered pair. Put in, I'm going to just put this one in, -1 equals 2 times -1 plus b, that's -2. When I add 2, b is 1. So my equation is y equals 2x plus 1. So linear, and there's the equation. Okay, now let's go over here and let's look at this example. Right here, 32 to 18. I'm pretty sure that is minus 14. And then we've got minus 10. And then we've got minus 6 and minus 2. Okay, first difference, not the same. So let's check the second difference. Plus 4, right? Plus 4, plus 4. I'm adding 4 because those negatives are decreasing, so that's why it's addition. So our second are the same, so it's quadratic. Now over here it says, remember you can't put 0, 0 in there. This one, when you pick a number to put in there, don't put that one. So y equals ax squared. That's all we're going to do. Pick a set of numbers. Let's go ahead and pick this one. So y is 2 and x is -1. Well, when we square -1, we get 1. So 1 times a is a, and a equals 2. So your equation, y equals 2x squared. That's simple. Okay, let's try the third one. I'm going to go out on a limb and say this one's probably exponential. But take a look. This is, let's see. Oh, I don't even know. the difference is not the same though, right? Because this is 3 plus 3. This is plus 1.5. This is plus 0.75, and this is plus 0.375. Okay, so that's the first difference. How about the second? 0.75 minus 0.375. Okay. And this is not, it's still not the same. So probably going to be exponential, but let's check our ratios. So 0.75 over 0.375, I just know because that's 2. I know 1.5 over 0.75, that's 2. I know 3 over 1.5 is 2. And I know I know that 6 over 3 is 2. So I know that my ratio equals 2. Now, I also know that my first term is 3, but in case you're not sure of that, so I know that it is exponential, which is y equals a, the ratio to the x power, and our ratio is 2. Now I got to figure out a. Pick a point. Doesn't matter. Let's do the 1 and the 6. If x is 1, y is 6. 2 to the first is obviously 2. So when we divide by 2, a is 3. So our equation, y equals 3 times 2 to the x power. There's our exponential function. All right, on to the next page. All right, just doing some real world stuff here. Okay, writing the equation for the real world situation doesn't tell us what it is. So we obviously have to figure out linear, quadratic, or exponential. So right here, looks like it's plus 12, and then it's plus 20, and then it's plus 28, and then it's plus 36. So first difference is not the same, it's not linear. So let's check second difference. Plus 8, plus 8, plus 8. Oh, there we go, second, so it's a quadratic. So the function we are going to use, y equals a x squared. Pick a point. I'm just going to pick this one right here. Put in x, put in 1 for x and y, 4 for y. 1 squared is still 1. So a is 4, so I've got y equals 4x squared. There you go. Second one, the book club. All right, notice our time is going up at a constant rate, so let's check our differences. Plus 5, plus 10, plus 20, plus 40, plus 5, plus 10, plus 20. So exponential. So we've got y equals a times the ratio to the x power. Now how do I find a ratio? 10 over 5, that's 2. 20 over 10, that's 2. 40 over 20, that's 2. 80 over 40, that's 2. Our ratio is 2. Now we got to find our first term. If you're not sure how to identify it in your table, pick a point. I'm just going to pick this one. Putting in 1 and getting 10 for y when I put in 1 for x, because 2 to the first is 1, 2 to the first is 2, divided by 2. A is 5. Take note right there. That's what it comes out when it's 0, if you need that hint. So y equals 5 times 2 to the x power. And there's that work. All right, so on the back of your page, you should have your homework assignment. it is all of that. Let me just make sure I don't think you need any graph paper. Oh, you do. You do need 3 graphs. So make sure you grab a piece of graph paper. That is for 14, 16, and 18. You want to graph those up and decide which one it is. And then the rest are good to go. Good luck. If you have any questions, come see me. Thank you.